Hello, now I'm going to introduce how to do a graph analyzing by using the Microsoft Excel. Okay, so by using the Microsoft Excel, we can determine what is the gradient, what is the y-intercept, what is the uncertainty for the gradient, uncertainty for the y-intercept, and for sure we can get the whole equations for a straight line based on the data given. Okay, so now let's go, baby. Okay, so here are the examples of the data where the L and the T squared. So the graph we are going to plot is the T squares against L. Okay, so now we go to the Microsoft Excel. So your first step, for sure, you need to key in what are the data for the x-axis and what are the data for the y-axis. Okay, after that, you just highlight the 4 columns. It can be anywhere. You want highlight here also can, here also can. Depends on you. Just highlight the 4 boxes here. Okay, after that, we go to the formula bar. Okay, we go to the formula bar. Here is a formula bar. Then we key in the formula. So what are the formula? You just key in equal and then minus. Okay, so please make sure the minus is in the capital letters. And then open bracket. Okay, so if you come out the formula here. Okay, so we have the 1, 2, 3, 4. Means that we need to key in 4 items. So the first one is show that non-yx. Non-yx means that the data for y-axis. So the first thing you need to key in is the data for y-axis. So you just go to your y-axis, then you highlight. And then here is the comma, right? So you just follow, it's a comma. And then now become the non-x-axis. So x-axis here is the data for x-axis. So you just highlight. Yeah. Then comma, just follow it. Okay, so you can see here is the blue color and the red color, right? So the blue color is for y-axis. The red color is for x-axis. Okay, next one is the constant. Here is a constant. Okay, what is mean by constant? There are 2. One is a false, one is a true. False is b is set equal to 0. True is b is calculated normally. Okay, what is mean by equal to 0? Means that your line is start with 0 for false. So if now our line is not start with 0, So in physics, normally our line is not necessarily start with 0. It depends on you to get the best fit line. Okay, so means that we want to calculate normally. So we key in the true. But just simple, the coding is false is 0 and true is 1. So you just key in 1. 1 is for true, where we want to calculate normally. Our line is not start with 0. Okay, last one is the statistical. Okay, true for return additional regression. False for do not return. Okay, so now we just want the basic information. We just want the gradient and also y-intercept and also the equations, right? We don't need any the regression, what are the errors, what are the standard derivation, all that one. Okay, we don't need. So do not. So we want the false on it. So for the false again is 1. True for 0. Here is a 0, here is a 1. So we keep it 1. And then cross bracket. Okay, after that, go to your keyboard and find where is the Control, Shift, and Enter. Control, Shift, and Enter. So we need to press the Control, Shift, and Enter at the same time, simultaneously. Okay, then please, you need to get it simultaneously. Press it. Okay, here you get the result. Okay, so this one, I change my decimal places so that it become constant. Okay, so what is mean by this one? 1, 2, 3, 4. Okay, so this one is a gradient. This is the uncertainty for the gradient. This is the y-intercept. This is the uncertainty for the y-intercept. Therefore, we can get the get the result by keying this formula only. Okay, now we back to our this one. Okay, so finally, here is a result. Okay, so here is a gradient, gradient, uncertainty for the gradient, the y-intercept, and also the uncertainty for y-intercept. Okay, therefore, these are the things you can get from the Linus function. So equations of a straight line from the data given just now is y equal to 0.039x plus with the 0.029. Okay, so means that after you sketch the graph on your graph paper, right? Then after that, you calculate the gradient. So you can check your gradient with here. See whether correct or not. Okay, so how to get the uncertainty? Just very simple. You can calculate it. You can calculate the uncertainty of the gradient by using the excell. Okay, just very simple, right? Okay, so hopefully you can understand and have a good try on it. Okay, thank you.